In this video, we're going to go over section 5.2, which is called Polynomial Division and the Division Algorithm. So you aren't going to use your calculator a lot in this section, but you will have to do some mental math. So I'm going to go ahead and flip my screen and we'll get started. Okay, so section 5.2, Polynomial Division and the Division Algorithm. We're going to start off and talk about the division algorithm. This is going to help us figure out how to write our answers. This is the division algorithm, and it looks kind of complicated, but I think once I tell you what all of these functions represent, I think it'll be pretty straightforward. So here we have P of x divided by D of x equals Q of x plus R of x over D of x. All right, so up here in the top, we have some polynomial being divided by some divisor. Or you could think of it as D just represents the denominator. So we have a polynomial divided by some divisor equals a quotient. Q represents the quotient plus the remainder over that original divisor. Okay, so this is how we will write our answers. We will take some polynomial, divide it by a divisor, and then we'll write our answer as the quotient plus the remainder over that original divisor. Now, sometimes our remainder will be 0, in which case we will just not write this part. So it would be 0 over the divisor, which would be 0. So whenever we don't have a remainder, our answer is just a quotient. But whenever we do have a remainder, this is the way that we write our answer. Now, before we get started with polynomial division, let me just remind you of how we do long division. So in case it's been a while since you've done long division, so I'm just going to make one up. Let's say we have 3 divided into, let's put 147. Right, so 147 divided by 3. So we would say, okay, how many times does 3 go into 1? 3 does not go into 1. So then we go to the next number. How many times does 3 go into 14? 3 goes into 14 4 times. Times 3 is 12. And then do you remember what we do at this point? From here we subtract. So 14 minus 12 is 2. Then we drop down our next number, which is 7. How many times does 3 go into 27? It goes in exactly 9 times. 9 times 3 is 27. We subtract again, excuse me. That leaves us with our remainder of 0. So that's our remainder. Our quotient. So the number on top is the quotient. This number is called the divisor. Number here under the division symbol is called the dividend. All right, so just a little reminder of some of those vocabulary words that it may be a while since you've used them. All right, so we're going to follow this same algorithm to divide polynomials. It'll just be slightly more complicated because instead of using just numbers, we'll have variables involved. So let's scroll down and talk about long division. All right, so we're going to jump straight into an example, but if you prefer to see a step-by-step process, you can see page 376 of your textbook for a step-by-step procedure for polynomial division. And in a minute after we do this example, I'll show you how to get to the textbook, just in case you haven't been using that feature on Hawks. All right, so let's do long division. with this polynomial. It says divide the polynomial x squared plus 2x minus 24 by the polynomial x plus 6. All right, so we're going to write this long division style. So x plus 6 is our divisor. Goes on the outside. We have our long division symbol there, or division box, whatever you want to call it. And then we have our dividend is x squared plus 2x minus 24. All right. So starting here, we would say, what do we need to multiply x by to get x squared? Or how many times does x go into x squared? X, we would multiply x times x to get x squared. So x times x is x squared. Then we have to do this part. We're sort of distributing that x. X times 6 is plus 6x. All right, and then at this point, if you remember, we subtracted. But not only are we subtracting this first piece, we need to subtract everything. So we're doing kind of like a distributing the negative type of thing here. So subtracting the x squared, but we're also subtracting the 6x. So we're subtracting both pieces. X minus x, x squared minus x squared is 0. That cancels out. Then we have 2x minus 6x is negative 4x. Okay, so we repeat the process. What do we need to multiply x by to get negative 4x? We would multiply by negative 4. All right, so do your multiplication or distribute that negative 4. And sorry, we need to drop this down too, don't we? All right, so negative 4 times x is negative 4x. We've dropped down this minus 24. Negative 4 times 6 is negative 24. Okay. Now we're subtracting both pieces. We have a double negative and then another double negative. So if you have a negative, it's going to change it to a positive. All right, so we're just sort of distributing the negative or flipping the sign here. Negative 4x plus 4x, that cancels out. Negative 24 plus 24, that cancels out as well. Remainder is 0. All right, so this number is your remainder. Up top, we have our quotient. Remember, this was the divisor. Side here, this is the dividend. All right, so if you remember how we're supposed to write our answer, we said if you have some polynomial divided by a dividend, sorry, a divisor, if you have some polynomial divided by a divisor, then that's equal to a quotient plus a remainder over the original divisor. All right, so that's how we're going to write our answer. So here's our solution. Our quotient, which is x minus 4, plus our remainder, which was 0, over the original divisor, which was x plus 6. Now, like I said earlier, when you have a remainder of 0, it just makes this whole part cancel out. So our solution is just x minus 4. Because 0 over anything is still going to be 0. So there's our solution. All right, let's scroll down here. I'm going to show you how to get to the textbook, just in case you would like to see a step-by-step procedure for polynomial division. So you would go to D2L and open up Hawks. I have to go in a different way. Actually, I think I can get in there the same way as you. Let me go the same way as you. All right, so we're just going to go to our class, go to content, click on any one of the homework assignments. Does not matter which homework assignment you click on, you can get to the textbook. All right, so you're going to click on ebooks. Now, I'm going to have several pop up here, but you're just going to have the one book pop up unless you've taken another class with Hawks. So click on our pre-calculus book and then go to chapter 5 and then 5.2. All right, so I told you it was on page 376, so you could just put it in the search bar up here, 376. And there we have our polynomial division steps, actually on page 375. 370. So those are the steps for polynomial long division. You can take a screenshot of those or take a picture of it, or copy it down on your index card if that's something that you decide that you want to have on your formula sheet. All right, so let's jump back over to our notes and do another example. This is another way that the questions may be presented. It says, use polynomial long division to rewrite the following fraction in the form the quotient plus the remainder over the divisor, where d of x is the denominator of our original fraction or the divisor, q of x is the quotient, and r of x is the remainder. So we have 3x cubed minus 3x squared plus 6x plus 12 divided by 3x plus 3. All right, so let's write this long division style. 3 plus 3, 3x cubed minus 3x squared plus 6x minus 12. So starting off here, what do we need to multiply 3x by to get 3x cubed? The coefficients are the same, but in order for us to get from x to x cubed, we would need to multiply by x squared. So we're going to multiply by x squared. X squared times 3x is 3x cubed. X squared times 3 is plus 3x squared. All right, remember, then we subtract, so we're just flipping the signs here. So minus and minus. Those cancel. Negative 3x squared minus 3x squared is negative 6x squared. Drop down our next term. Plus 6x. All right, now we're asking ourselves, what do we need to multiply 3x by to get negative 6x squared? We would need to multiply by negative 2x. All right, so negative 2x times 3x. Negative 2 times 3 is negative 6. X times x is x squared. All right, now multiplying by 3. Negative 2x times 3 is negative 6x. All right, so flip your signs. That becomes a plus. Oh, that looks terrible. Let me try that again. Okay, that one becomes a plus as well. All right, so add them together. Negative 6x squared plus 6x squared cancels. 6x plus 6x is 12x. Drop down your next term. Minus 12. All right, now repeating the process. What do we need to multiply 3x by to get 12x? By 4, right? So plus 4, positive 4. 4 times 3x is 12x. 4 times 3 is 12, plus 12. All right, draw your line, flip the signs. Minus, minus. 12x minus 12x cancels. Negative 12 minus 12, negative 24. That's our remainder. There's nothing else we can drop down, so we're done. That's our remainder. Here's our quotient. Here's our divisor. That's the 3 things we need to write our answer. All right, so our solution, our answer. Remember they said it's quotient plus remainder over divisor. All right, so quotient is x squared minus 2x plus 4 plus remainder is negative 24. Divisor is 3x plus 3. Now, the last thing that I would do is go ahead and just simplify this. Plus a negative is just a minus. So I would go ahead and simplify that. Makes it look a little bit neater. So there's our answer. Oops, sorry. All right. Let's scoot down. I think we have, oh, okay, so that was our last example with long division. Now, as you could tell, I really think this was a good example for you to see how we're repeating this process over and over. We keep asking ourselves, what do we need to multiply 3x by to get a certain term? So since that process is so repetitive, there is a faster way that we can do that using a method called synthetic division. Right, so synthetic division version of long division that can be used when the divisor is written in the form x minus c. So the divisor has to be written in the form x minus c. That's very, very important. Sorry, trying to get everything off of the screen. All right, so it's a shortened version of long division that can be used when the divisor is written in the form x minus c. Now, you can use it for other types of problems, like we just saw that last problem that we did. Let me just scoot this up instead of rewriting it. But notice that our divisor had a coefficient, had this 3 out front, so 3x plus 3. Now you can still use synthetic division for that. You just have to do a little bit of adjusting to make the divisor match this form. All right, so whenever we are doing long division, let's start off with an easy one. I'm going to come up with a little easy example out here with simple numbers. Let's say 2x squared minus 5x plus 7 divided by x minus 3. Okay, so we'll start off with a super simple example like this. All right, so here's how you always want to start whenever you're using synthetic division. You want to think, okay, synthetic division, divisor's got to be in the form x minus c. So I'm going to go to my divisor, say, okay, it's got to be in the form x minus c. So I got to match up and determine what is c. X matches with x plus, excuse me, not plus. Let me start over. X matches with x. Minus matches with minus. C matches with 3. Right, so C is equal to 3. Now that's important because that's the number that's going to go over here in a little box by itself. Okay. Now beside it, beside that number 3, we are going to write the coefficients of our dividend up here, the polynomial in our numerator. So that's 2, negative 5, and 7. 2, negative 5, and 7. All right, so just to make sure we're all on the same page, first thing you do is determine what is the value of C. You write it under here, you match up, you say, okay, what does C match with in my problem? So C is 3, you put it in a little box by itself. Right, I guess it's really like a half of a box. Beside that number, you write the coefficients of your dividend. All right, now you're going to skip a line. So skip a line, then long straight line under those coefficients. All right, now the first term always drops straight down. Always, that happens every time. Once you've dropped down that first coefficient, then you're going to start multiplying. 3 times 2 is 6. All right, so if you're following along, this is how that just went. 3 times 2, and we're going to write it here. 3 times 2 is 6. Then you perform the operation. You don't flip any signs here. So negative 5 plus 6. This is a positive number, so we're adding. Negative 5 plus 6 is 1. Now repeat the process. 3 times 1 goes here. 3 times 1 is 3. Perform the operation. These are both positive, so we're adding. 7 plus 3 is 10. Right, that's our answer. It doesn't look like our answer right now, but that's because we have to add back in our variables. Now we can look at our dividend up here, and we see that it is degree 2. We know that because that's the highest exponent. So the dividend has degree 2. The divisor, or the quotient here, I should say, the quotient will always be 1 degree less than the dividend. So quotient is 1 degree less than the dividend. All right, so that means our highest exponent this time will be 1 less than the dividend. All right, so 1 less than 2 would be 1. So that means highest exponent is going to be 1. So now we start filling in our variables. All right, so that's x to the first power. We don't need to write that first power. You can leave it off. This is a positive 1. And then this last number out here is always your remainder. All right, so that's going to be plus 10 over our original divisor, which was x minus 3. So there's our solution. Our solution, problem I made up, is 2x plus 1 plus our remainder over our divisor. Let's look at a more complicated example. All right. Let's look at this one. This one looks pretty bad, but I think it's just a lot of terms. I don't think it's going to be particularly difficult. All right, so we see this, we think, okay, this is kind of a complicated or a long dividend. Anytime you see a long dividend, synthetic division is going to be helpful. It's going to cut down on a lot of the work you have to do. So we're thinking, okay, synthetic division is probably a good option here because our dividend is really long. But for synthetic division, the divisor needs to be in the form x minus c. All right, so we go down here to our divisor. We say, okay, well, it almost matches, but this one, we're supposed to have a minus. We have a plus here. That's no problem. You go off to the side. You can make some adjustments and make this match up with x minus c. Another way we can write a plus is as a double negative. All right, so instead of writing a plus here, let's write this as a double negative. All right, so now let's match this up. X matches with x. This minus matches with this minus. Sorry, my arrow got a little crazy there. All right, so x matches with x. This minus matches with this minus. C matches with negative 2. All right, so there's our value for C. All right, so that goes off in a box by itself. And we write the coefficients of our dividend. So you have to be careful with synthetic division because if you'll look here, there's a missing term. We have 4x to the 6th plus 8x to the 5th. Then we skip the x to the 4th term. So no x to the 4th term. That's very important. It's very important that you notice that. So we skipped that x to the 4th term and we went straight to the x to the 3rd term. So that means that for that missing term, you need to fill in a 0 as the coefficient. All right, so let's write that down here off to the side. fill in a coefficient of 0 that kind of looks like a 6. All right, fill in a coefficient of 0 for any missing terms. When using synthetic division. Very important note. Okay, so let's start writing the coefficients. 4, 8. Space them out a little bit. So you don't want them to get too close because then it might look like 48, for example. All right, then we had that missing term, so we're filling in a 0. Then -6, -12. All the while, we're looking for any more missing terms, x to the third, x squared, x. So no missing terms here. After that, x to the fourth term. All right, then we have a coefficient of 5 and then 10. All right, so then skip a line, long straight line under the coefficients. All right, let me zoom in here, kind of get all this unnecessary stuff off the screen so we can focus on this. Okay. Remember we said the first term, the first coefficient always drops straight down. Then we start multiplying. -2 times 4 is -8. Then perform the operation. Don't flip any signs. 8 minus 8 is 0. Multiply again. -2 times 0 is 0. Perform the operation. 0 plus 0 is 0. Multiply again. -2 times 0 is 0. -6 plus 0 is -6. Multiply again. -2 times -6 is +12. -12 plus 12 is 0. -2 times 0 is 0. 5 plus 0 is 5. -2 times 5 is -10. 10 minus 10 is 0. Synthetic division is done. Now from here, we're just writing our answer. So let's scoot back up here. Look at our original dividend. It was degree 6. All right, so degree 6, highest exponent is 6. That means our quotient or our answer is going to be degree 5. All right, so you can start filling in the variables. All right, so that's degree 5, so it's x to the 5th plus 0 times x to the 4th plus 0 times x to the 3rd minus 6 times x squared plus 0 times x plus 5 plus, this is our remainder. And of course, we would write it remainder over our original divisor, which was x plus 2. All right, now let's write our solution. We don't need to write any of these terms that have a 0 as the coefficient because 0 times, for example, 0 times x to the 4th is just 0. All right, so here's our solution. 4x to the 5th. Whoa. That goes away. That goes away. That goes away. That goes away. All right, so 4x to the 5th minus 6x squared plus 5. Done. All right, so I'm going to try to get the whole problem on the screen. This was not part of it, so you can ignore that stuff. So there's the problem. This is a great problem for the test. I would probably not make it quite as long, maybe something like a degree 4 instead of a degree 6 dividend. But this is a great problem for the test. You could use synthetic division, you could use long division, whatever your preference is. I don't ask that you use a certain method because you'll get the same answer either way. So it's totally up to you as to whether or not you want to use synthetic division or long division. All right, we have one more here, kind of an easy one compared to the one we just did. So let's take a look at this one, and I think that's going to wrap up this section. All right, so 2x to the fifth minus 10x to the fourth plus 11x cubed minus 9x squared minus 12x. No constant term, that's fine. We had no missing terms. We went x to the fifth, x to the fourth, x to the third, x squared, x. So no missing terms. So we're going to jump straight into matching up, determining what our value of c is. X matches with x, minus matches with minus. So c is 4. So 4 goes over here by itself in a little box. Then we write the coefficients of our dividend. 2, negative 10. Whoa. 2, negative 10. 11, negative 9. Then negative 12. You can fill in a 0 for the constant term if you want to, but you don't have to. Let's fill it in, and just so we're remaining consistent. Okay, so now, oh, no, we have one more down here, but we just did that one, so we don't have to do it again. All right, so let's look at our synthetic division problem here. We always drop down that first term, that first coefficient. That's a 2. Start multiplying. 4 times 2 is 8. Negative 10 plus 8 is negative 2. Multiply again. 4 times negative 2 is negative 8. Perform the operation. 11 minus 8 is 3. Multiply again. 4 times 3 is 12. Negative 9 plus 12 is 3. 4 times 3 is 12. Perform the operation. Negative 12 plus 12 is 0. 4 times 0 is 0. 0 plus 0 is 0. All right, now we can jump into writing our answer. I'm going to scoot up here, look at our dividend. This was degree 5. Degree 5, so that means our quotient or our solution is going to be degree 4. All right, so that's going to be x to the fourth minus 2x to the third plus 3x squared plus 3x plus 0 plus our remainder. Of course, we write that over our divisor, which was x minus 4, I believe. Yes. All right, so again, we do not have to write the ones that have a 0 as the coefficient. So you can take out that constant term, take out the remainder, and now here's our solution. 2x to the fourth minus 2x cubed plus 3x squared plus 3x. That's it. All right, so hopefully that gives you a good start for polynomial division. Like I said on the test, I tell you in the directions that you can use either one. So it is totally your preference which one you choose. One of the most important things I would like you to take away from this lesson today is if you are using synthetic division, which is my suggestion, I think it's a little bit faster and a little bit easier. But do remember that you have to fill in a coefficient of 0 for any missing terms when you're using synthetic division. So always kind of look through the dividend before you start and see if you see any of those missing terms. So here we saw it went from an x to the fifth term to an x to the third term. So we were missing that x to the fourth term. All right, so if you do have any questions about polynomial division, please feel free to send me an email. Otherwise, I'll see you guys in my next video. Have a good day.